Good morning to all. In the last class I taught you about one of the most important problem in the central class, right? In this class I am going to teach you about a problem in the screw friction. Read the problem. An electric motor driven power screw moves a nut in a horizontal plane against a force of 75 kN at a speed of 300 millimeter per minute. The screw has a single square thread of 6 minute pitch on a measure of 40 mm. On a measure of 40 mm, the coefficient of friction at the screw threads is 0.1. Estimate power of the motor. Estimate power of the motor. Right? First we need to write the given data and understand the problem. Right? How you can write? They given the electric motor. It's an electric motor setup, right? It has a power screw moves on a nut, right? And its arrangement is available in the horizontal plane. Available in the horizontal plane. And there is a force that is 75 kilonewton. It's available in the kilonewton. So we need to convert into Newton, right? Into 10 power 3. And they given the speed in the mm per minute, which unit? The speed in terms of mm per minute. So it's a velocity, right? Velocity small v equal to 300 mm per minute. And they given the pitch 6 mm, right? 6 mm and the measure of 40 mm and coefficient of friction 0.1, right? What we need to find? Estimate the power of the motor. Estimate the power of the motor. Power of the motor only we need to find, right? How you can find this power? How you can find this power? With the help of the formula only we can able to find the power, right? What's the formula for finding the power? The formula is T into omega. T is the torque, omega is the angular speed, otherwise angular velocity, right? Omega we can find with the help of formula 2 pi n by 60 directly. But we need to find the value of torque first. Torque required to overcome the friction. That we need to find. Then only we can able to find the value, right? So we need to find the mean diameter of the screw first. That is D equal to D naught minus P by 2. P is the pitch. D naught. So both the value we know. So we can substitute both the values here and find the value of mean diameter of the screw. Right? The value will be 37 mm. After finding the mean diameter of the screw, we need to find the value of alpha. Tan alpha equal to P by pi d. Here also we know all the values, so we can substitute all the values. Here also we can substitute all the values. And find the value of alpha. Which value will be in mm. That's why we are substituting the diameter value will be mm. So that's why here is the value of alpha is 0.0516. Then we need to find the value of force required at the circumference of the screw. Right? Why we are finding this force required means we need to find the value of torque. That's why, right? What's the formula for force required? The W tan alpha plus pi. We need to elaborate the tan alpha plus pi formula. Tan of A plus B. With the help of that formula, we need to elaborate that. The formula will be the W into tan alpha plus tan pi divided by 1 minus tan alpha tan pi Here we know all the values here. Here we know all the values. So we can substitute all the values in this equation and find the value of force required. The value will be 11.43 into 10 power 3 Newton. 11.43 into 10 power 3 Newton, right? After finding the value of force required, we need to find the value of torque. We need to find the value of torque required to overcome the friction. Torque required to overcome the friction. What is the formula for that? Torque required Q equal to force required into d by 2. Right? So, here we know force required and diameter, mean diameter value. So, we can substitute both the values in this equation and find the value of torque required. The value will be 211.45 Newton meter. 211.45 Newton meter, right? So here we found the value of torque required. So finally we need to find the value of power. How you can find the value of power? First we need to find the value of mean speed, speed of the screw, right? That we can find with the help of this formula, the speed of the nut divided by pitch of the screw. With the help of this formula we can find the speed of the screw, right? So with the help of this formula we need to find this value. The value will be 50 rpm. The value will be 50 rpm, right? After finding that we need to find the angular speed, angular velocity for that screw. Angular velocity for the screw. The formula will be 2 pi n by 60. Here also we know the value of speed here. So we can substitute those values and find the value of angular speed. The value will be 5.24 radian per second, right? After finding the value of angular speed and as well as torque required to overcome the friction, we need to substitute those values in this power required, right? Otherwise, power of the motor. Both the value we can substitute here and find the value of power of the motor. The value will be 1108 watts. Finally, we will get the value, power value will be 1.108 kilowatt, right? In the next class, I will teach you about the another most important screw friction problem. Thank you.